All right, section 6.3 is about using similar polygons. So we are still going to be using proportions today to identify similar polygons. First up, what did we get for x on that first warm-up? What did we get? 72, good. When you cross multiply, or really even when you look at this, you probably could have seen the relationship, times 6 times 6. Either way, x is 72. If you cross multiplied and showed all of that, that is wonderful. The scale of a map is 1 centimeter to 10 miles. The actual distance between the town is 4.3 miles. Find the length of the map. Okay, now if you did this a different way, that's fine. I'm going to show my work on this one using proportions. So we have 1 centimeter to 10 miles, which means my other ratio needs to have what on top and what on bottom?
X on top, 4.3 on bottom.
Good. X on top, 4.3 on bottom. Keep it consistent. Yesterday we talked about that the model or the drawing would go on top. The actual would go on the bottom. So we can cross multiply to get 10x equals 4.3. Last thing we would need to do to solve this, divide. So what does x equal? Good, 0.43 centimeters. Make sure that you are always putting a label where it is appropriate. Yes, ma'am.
If I were to just take 4.3 and divide it by 10.
If you show me your work, that's fine. I will take it. Okay. I would recommend proportions, especially if you're not super great at knowing which way to go. I've had students in the past that would be tempted to put 43 because they're like, oh, if I multiply by 10, that's nice. It gets rid of the decimal. So if you're not sure which way it's going, if you should be multiplying or dividing, definitely show a proportion. If you know which way to go right away, as long as you show me what you did, that's fine. Okay. Other questions? Okay. A model train is 9 centimeters long. The actual engine is 18 meters long. What is the scale of the model? I would accept this a couple different ways. The way that I would go about it initially... Oh, not centimeters, meters. Yesterday what we did was we made the denominator into a 1. That sort of works. Another way you could do it is simplify it as much as you can, and that would be an acceptable scale. So what would this fraction simplify to be? 1/2. So 1 centimeter to 2 meters would be an acceptable scale for it. You could write it with the colon if you prefer. If you do things like changing your units to be the same, your answer could look a little different. Okay. As long as it's equivalent to what we have here and it's reduced for the units that you have, I will accept it. Questions about any of our warm-ups? All right. 2 polygons are similar polygons if the corresponding angles are congruent and the corresponding side lengths are proportional, meaning they're in the same ratio. This is going to feel similar to when we did congruent polygons or congruent triangles, because we will still have angles that are congruent. But this time the sides are not necessarily going to be congruent. They'll just be proportional. Okay, so you can see here they show us that these are similar. They are not congruent because they are not exactly the same. The symbol for similar is a squiggly or a tilde, some people call it if you take Spanish. Or it's like a congruent symbol without the equals part. So you could think about it, the sides aren't equal, so we're not going to put the equal sign. So example 1 tells us that figure ABCD is similar to figure MNOP. We are asked to name the congruent angles. You can do this even if they don't give you a picture. Much like when we did congruent figures, the statement gives you all the information you need. Meaning, angle A is going to be congruent to angle M. Okay, the angles are congruent, so we will actually use a congruent symbol. It's just that the figures are not necessarily congruent overall. Angle B is congruent to angle... Give me another pair. Angle D is congruent to angle P, the last one we need. Good. Angle C is congruent to angle O. No, it does not matter to me which order you put them in. It doesn't matter to me if A, B, C, D is on the left or the right, as long as you have your correct pairs. Questions about the angles? That part should be easy because it is just like when we did congruent figures. Write the ratio of corresponding sides. One side note I want to make about this is that this ratio, and I'll write it off to the side here, it's called a proportionality statement. Ooh, I'm running out of room. Ooh. That didn't work. Proportionality statement, meaning that we're going to use proportions to do it. Okay, so if you see that phrase, proportionality statement or statement of proportionality, that's what they mean. What do ratios usually look like for us? Fractions. How many fractions do you think we need? If we're talking about the sides. 4 of them, because each figure has 4 sides. So for a triangle, you would only have 3 ratios or 3 fractions. However many sides you have, that's how many fractions are going to be part of this proportion. Give me a side from figure ABCD. AB, sure. So we'll put AB in the top of this ratio. What side from the other figure do you think corresponds to side AB? MN, very good. Again, you could do this without the picture. AB are the first 2 letters, MN are the first 2 letters in that similarity statement. Move on. Give me a different side from ABCD. Which side? We just did AB. Oh, AD, sure. AD is a different one. What side corresponds to AD? MP. Give me another one from ABCD. EC corresponds to NO. Last one we need. DC or CD, whichever way you want to put it, corresponds to PO or OP. One thing you do need to be careful with is that you have to be consistent with which sides are on the top and which sides are on the bottom. When you do the angles, I don't care which one's on the left or right. But when you do a statement of proportionality, we can't just flip-flop one of these ratios in the middle. If we were to flip one, we'd have to flip them all. Does that make sense? Okay, because it's one big statement. Questions about example 1? Okay, in this case, you could, if you really wanted to, label in your diagram your congruent angles. You don't have to, but you could. Could we put any sort of markings on the sides? No, because we do not know that they are the same. We only know that they are proportional. Okay, so we would not mark the sides even if we wanted to mark the angles. Questions, concerns? Okay, we didn't have to mark the angles, just if you want to. All right, we'll move on. So we have a note that any two identical figures are congruent. They are only congruent if they are identical. We talked about that last semester. I'll add another note under this, though, that any two congruent figures, and I'll shorten it up here, are going to be similar. So this is one of those things where it's kind of a one-way street. If it's congruent, it's definitely similar. But if it's similar, that does not mean that it's congruent. Does that make sense? Okay, if it's congruent, they are similar. But just because they're similar does not make them congruent. If two polygons are similar, the ratio of the lengths of two corresponding sides is the scale factor. We would have talked about a scale factor when we did dilations. You remember that project we had where you took the shapes and you made them into different shapes and you plotted them and made a picture out of them? We did rotations, reflections, translations. The last one was dilations, which we didn't spend as much time on. Dilations get multiplied by some scale factor, creating similar figures. Whereas the other ones, rotations, reflections, and translations, those all made congruent figures. All right. Example 2. Is triangle ABC similar to triangle DEF? Two things need to be true for similarity, and we might be repeating them a lot. What are the two things, or what's one of the two things we need to check for similarity? Congruent angles is one of them. Corresponding congruent angles. What's the other thing we have to check? Proportional sides. Very good. That's the word that I like to use. Proportional sides. Yes, we want to make sure the scale factor would be the same all the way around. That would mean that the sides are proportional. So anytime you're asked if two figures, triangles, quadrilaterals, anything else, if you're asked if they're similar, you need to check these two things. So first up, do we have congruent corresponding angles? Yeah, how do you know? Because of the little lines they put in there. They marked them for us. There's really nothing for you to show in this case. You checked that the angles were congruent. For proportional sides, however, you do have a little bit of work to show. We have to see if all of these ratios end up reducing to the same scale factor. When you do this, I want you to be careful, because your figures will not always be oriented in the same direction. This one, it makes it pretty easy to pair up your sides, but if they were to turn it or give you different types of shapes and rotate them around, it'll be a little bit trickier. So my suggestion here is that you're always matching up your smallest side to your smallest side. And then your next smallest side to your next smallest side. Then your biggest side to your biggest side. Go in some sort of order. If you'd rather start with the biggest ones and work your way down, that's fine. But you cannot mix and match sides or you won't come to the right conclusion, most likely. With all that being said, give me the smallest side of the first triangle. Okay, 8. will get compared to which side from the other one? 12. What would that reduce to? Okay, divide them by 4, we'd get 2/3. We're just going to let that sit there. We're going to move on and check another pair. What's the next smallest side? 10 gets compared to, that reduces to, okay, we're off to a good start. The biggest side compared to reduces to, okay, divide them by 6, you get 2/3 again. So if you end up with the same exact ratio every single time you match up corresponding sides, then yes, they are proportional. So in this case, are they similar? Yes, they are. Okay, last up, they asked for the scale factor of triangle ABC to triangle DEF. The nice part about that is that we already found it 3 times. What is it? 2/3. One thing I want to point out to you though is that you need to be careful with how they ask you for the scale factor. If they had said find the scale factor of triangle DEF to triangle ABC, 2/3 would be wrong. What would it have to be? 3 halves. Okay, so make sure you're paying attention to which way they go about it. They said ABC to DEF, and that's how we set these up, so we could just keep it. If they'd flopped those, we'd have to flip our fraction. Questions about example 2? Need more time with it. Okay? In the diagram, we are told we have similar triangles. We are asked to find the value of x. Do we care about the angles? No. We know that we have congruent corresponding angles, but they don't really matter to us in this case. We're worried about the sides. So we need to set up a proportion in order to solve this. If you don't know all the sides, you cannot match up small to small, big to big, because you don't know if this x is going to be the smallest side or the biggest side or somewhere in between. You might think it looks a certain way, but remember, you cannot go based on looks. So we go to our similarity statement. Give me one ratio we could come up with from that statement. Ratio meaning fraction. AB compared to HG or GH. Another one. Over. Okay. We don't necessarily need all 3, but for practice, let's go ahead and write it. What would the third one be? Compared to GJ or JG. Okay, so we have to rely on our proportionality statement to help us out here. You don't need all 3 of them. You need one of the ratios that you know both numbers of, and the other ratio better include the sides you don't know. So which one do we absolutely have to use? Okay, we absolutely have to use BC over HJ because that one includes the side we don't know. For the other one, since they gave us all the sides, it doesn't matter which one you pick. Which one do you want to use? Okay, A, B, and GH. So if we plug into AB, what do we have? 12 over 8 equals X over 16. If you had used AC and GJ instead, your answer should come out the same in the end. To solve proportions, we should cross multiply. 8x equals 12 times 16. Divide by 8. What do we get? 24. That's all they wanted was the value of x, so we're done. Okay, no, I do not expect you to write out your proportionality statement every single time you do one of these. If it helps you, you can, or at least to write out part of it. I think it's most helpful when the figures aren't, again, oriented in a similar way. Need more time before we go on? Then on we go. Note, if two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygons. When it says any length, what that means is that we don't necessarily have to just be working with sides of our shapes. We could be working with things like diagonals or other corresponding important lengths. Does that make sense? When it says any, we're not just talking about the outer edge. We could be talking about lengths that are inside of the figures. Questions, concerns about that? It's got to be proportional or in the same ratio all the way around. So let's practice using that. Given that these two triangles are similar, find the length of the altitude NL. Now, if that's what they're wanting us to find, I'm going to go ahead and put an X by it. That's what I'm looking for. So when we set up our proportion, what do you think X is going to end up getting compared to? 14, good. The altitude from the other triangle. Questions about why we would compare X to 14? What? Yeah, they're both altitude, so we would want to compare them to each other. So altitude from the top one compared to altitude from the bottom. We do still need another ratio in our proportion. So what are our options for what we could put in the top here? MN or NP. Okay, it's got to come from this top triangle if the X came from the top triangle. To me, it does not matter which one you choose. Which one do you want to use? The 27 or the NP? If we put 27 in the top, that was NP, what has to go in the bottom? The 18 or the ST. Again, I would not always go just based on what the figure appears to be to you, how it appears to be oriented. If you have a similarity statement, you better be double checking and making sure you're pairing up the right sides. If you wanted to use the 30, you would have had to put it over the 20. And if you did that, that's fine. To solve this, once again, we will cross multiply. 18x equals 14 times 27. When we divide by 18, what do we get? 21? Yes.
Does it matter if we have, for like, the fraction part, does it matter where the numbers go, like if it's on top or bottom? Well, like if it's the same.
If you're being consistent, I don't care. We talked about yesterday, you could have set this up 14 over x equals 18 over 27. Yeah, if you're using one of those equivalent proportions that we talked about yesterday, it doesn't matter to me as long as you show me what it is. Good question. Other questions? We're sure? Warm, fuzzy feelings all around? Good. Good. It's a Friday, even though it's going to rain forever. We should still have warm, fuzzy feelings on a Friday. All right, your homework is on the board. It's also on your assignment guide. Remember, you should be looking over your notes in preparation for our review on Monday, quiz on Tuesday.